So here we have two exam questions on algebraic fractions. And before we tackle them, let's just look at the examiner's remarks, which will show us how well or otherwise these were tackled in the real exam. So let's bring up both of them, in fact, have a look at the whole thing. The exam remarks say, first of all, this question was not well answered. The various steps to the full solution proved too difficult for the vast majority of candidates. Many just cancelled the 9x squared with the 3x squared here, so they made no progress at all, because obviously you can't do that when it's attached to another term here, so you can't simply cancel across here. Those who knew how to factorise often obtained the difference of two squares, so we'll have a look at that, but they wrongly factorised the denominator in the first fraction, so this expression here. The step of turning the second fraction upside down and multiplying was the next hurdle, and many couldn't do that. Many failed at this point. Most of those who managed this step were successful, although some failed to cancel or did some further cancelling that they didn't need to do. Okay, so it seems as though many people just didn't know how to proceed with something like this. With this one, it seems there were an equal number of problems. This first question, by the way, is worth 5 marks, and this second one is worth 6. So there will be lots of steps, so something that doesn't look too bad, in fact, proves to be quite a challenging question. Too challenging, it says, for all but the most able students. Some used trial and error, usually unsuccessfully, so not a good idea, while many were unable to make any real progress. It was very clear that many students just didn't know how to deal with the denominators, and many of those who did introduce errors when expanding the brackets, and they have this 5 times x plus 2 and 4 times x plus 1 were common errors. So let's deal with these one at a time. Let's remove the remarks and start with this one here. So what have you got to do? Well, I think the first thing I would do is something in the examiner's remarks they said they dealt with secondly, but I think this would be the first operation I would want to do, which is whenever I've got a divide by a fraction, I want to just flip that fraction upside down and change that to times. So I'm going to rewrite this out here. 9x squared minus 1 divided by this 3x squared plus 2x minus 1. Okay, so that stays the same, but instead of divide, I'm going to multiply. So I've got let's remove that. Let's just change that fraction by as well, because that got a little bit messy. Okay, so I'm going to flip that fraction upside down to give me x minus 2 in the numerator now, and 3x plus 1 in the denominator. So that's the first step, and that's just rewriting it, and now we can begin to work things out. Now I'm going to start with this one here. 9x squared minus 1, as they said in the examiner's remarks, is a difference of two squares. So what you've got, in other words, is you've got, well, 3x, which is the square root of 9x squared, plus 1 times 3x minus 1. And as long as you can recognise the difference of two squares, you can go straight to that step. And if we multiply out, we can see 3x times 3x is going to give us 9x squared. The middle terms are going to cancel. So we've got the outer 3x minus 1 is minus 3x, plus the inner 1 times 3x is 3x. So those cancel. Minus 3x plus 3x cancel. And we just get the last term, the 1 times the minus 1. Giving us our minus 1 here. So that's factorised the numerator here. And then I can multiply by the x minus 2 so that I can join these together now. So single fraction bar, like that. And underneath, well, I've got to factorise this as well. Now to factorise this, I suggest what we use is a nice structured method. So instead of doing it by a kind of trial and error process, I'm going to go over to one side here, give myself a bit of scaffolding, and use product and sum. So 3 times minus 1 is the product, so 3 times minus 1 is minus 3, and the sum is this term in the middle, so 2. So, not many options here. I'm going to look at 1 times minus 3, so minus 3. 1 minus 3 doesn't give me my 2 here, but if I now go to the other option, which would be 3 times minus 1, well, 3 times minus 1 will give us our minus 3, and 3 minus 1 gives us our 2. So here are the figures that are going to help us to split that middle term. So in other words, if I put this into a grid form now, like that, I can work out my factors by filling in the grid, 3x squared then, and then working out the sides. The other one I know already is negative 1, minus 1. And now using these numbers, I've got 3x and minus x. So I've now got 4 terms, which will enable me to find my factors. So where am I going to put my 3x? Here. And 3x times x will give me my 3x squared. So now it just remains to find the other parts of the side. So x times something gives me minus x. Well, that's got to be minus 1. Minus 1 times x gives me minus x. And the 3x here, well, that's going to be plus 3 then. So 3 times 3x, plus 1. Good job, I did a back check. So 1 times 3x gives me my 3x. And just to check the final box, 1 times minus 1 will give me my minus 1. Okay, so that's my little side work there. Now back to the problem. So what I've got here are my 2 factors. So I can write those out. Doesn't matter what order. So we've got x plus 1. And here we've got 3x minus 1. And lastly, I've got my 3x plus 1 as my end term here. 3x plus 1. And once you've done that, once you've got to this stage, it's just a case of looking at the numerator and the denominator and seeing if there's any cancellation that can be done. And indeed, there's quite a lot, isn't there? These middle terms here, 3x minus 1, well, that will cancel with the 3x minus 1 in the denominator directly underneath it. And this 3x plus 1 cancels with the 3x plus 1 here. That means I'm just left with x minus 2 and x plus 1. And to finish, I can just drop the brackets, giving my answer as x minus 2 over x plus 1. Okay, so step by step, hopefully that was very clear. You should be able to work through problems like that and without making any slips get the correct answer. Let's have a look at this one then. Now with this one we've got a slightly different situation because we've got a plus. So what we've got here is just the same as with ordinary fractions. We need to find a common denominator before we can join these two together, hopefully then to solve for the answer is 2. So we're going to find a common denominator first, and the only way to do that is, and the simplest way of doing that is by multiplying these out. So this term here will be multiplied by x plus 1 over x plus 1, and this term here will be multiplied by x plus 2 over x plus 2. So it's going to now expand quite a bit, and then we're going to simplify and solve for x. Okay, let's give this a go then. So let's start here by just making that expansion nice and clear. So we've got 5 times x plus 1 over x plus 1 times x plus 2. That's the first one. Second one is 4 times x plus 2 over x plus 1 times x plus 2. So, as above, I could cancel the x plus 1 and the x plus 1 here, leaving me with my term that I had here. And with this one I could cancel the x plus 2 with the x plus 2 in the denominator, leaving me again with this. But why I've done this is so that I can then multiply out the brackets and solve for x. So finally I need to write the answer is equal to 2. Okay, now step by step we're going to expand this then. So the first step is to deal with the numerator. So we can now join these together. So we've got 5, and we're going to multiply both terms in the brackets like this. So the 5 times the x gives us 5x, and the 5 times the 1 gives us 5. Now we can add these together. So we've got 4 times x giving us 4x, and 4 times 2 giving us 8. That's the numerator. The denominator, maybe we want to at the moment leave as 2 factors, because it might be that when we join this together we can cancel. So we just leave this at the moment as x plus 1 times x plus 2 in the denominator. Okay, next step. We'll write equals to in a moment. Let's just gather like terms. So we've got 5x plus 4x, that's going to be 9x. And we've got 5 plus 8 equals 13, so plus 13. Here's our fraction bar. Now I am going to, because I can see this isn't going to cancel, I am going to expand these brackets. So we've got rid of all the brackets. So we've got x squared. So foiling, x times x gives us x squared. X times 2 gives us 2x, plus another x gives us 3x. And our last terms, 1 times 2 gives us 2. So I could have written that out as a grid, but fairly easy to do it just by foiling. X times x, x squared, x times 2, 2x, 1 times x, x, and finally 1 times 2 gives us 2. So I'm certain that this is the correct step now. I can put it equal to 2 and think about what I do next. Well, what I'm going to do next is rearrange this equation, because I don't want this in the denominator now. I want a single line, so I want to make it, let's just put a little separator here. Okay. So I want to make it, I want to bring, if you like, that denominator over to the other side. So if it's dividing on the left-hand side, when I bring it over to the right, it's going to be multiplying. So my next line is going to be 9x plus 13 is equal to 2 times x squared plus 3x plus 2. Okay, and now I can multiply out this bracket to give me 9x plus 13 is equal to 2x squared, and multiplying the 2 through the bracket, plus 6x, and 2 times 2 gives me 4. Okay, now finally I'm going to put everything, I'm going to gather like terms and put everything equal to 0. So if I go to the next line here, I'm going to have 2x squared. Now I've got plus 6x, but I want to bring that 9x over, so it's going to be 6x minus 9x, giving me minus 3x as my x term here. And I've got 4 minus 13, well that's going to be minus 9. Equals 0. So you can see why this is worth 6 marks, because you have to go through these various stages. We've now got to the point where we've got a quadratic equation equal to 0. So to solve that quadratic equation, I'm going to have to do just as I did before. I'm going to find the 2 factors, so I'm going to factorize, and then I'm going to be able to solve for x, and it will give me 2 answers in all likelihood. Okay, let's have a look. So again, if I move over to work on the side here, I'm going to, there's not a lot of space here, so let's just use this space here. I'm going to, again, give myself a bit of scaffolding, use product and sum. So I've got 2 times minus 9, so 2 times minus 9 gives me minus 18. And in the centre I've got minus 3x, so the sum is minus 3, so they have to add to minus 3. So nice figure to work with. 1 times minus 18 is my first attempt, but that won't give me my minus 3, so I'll try 2. 2 times minus 9, well, 2 minus 9 won't give me minus 3. What if I try 3 though? 3 times minus 6, 3 times minus 6, 3 minus 6 gives us minus 3. So we've got our numbers that are going to help us to split our equation. Split our quadratic, I should say. Okay, so we're going from 3 terms now to 4 terms. So the best way of doing this is to fill in a grid. So here are our 4 boxes. So we already know 2 of these terms. So it's this term and this one we can fill in. And now we know how to split that minus 3x. So it's going to be made up of a minus 6x and plus 3. Plus 3x. So we need to now find our factors. We're going to go along here. So let's have 2x here, see if that works. So 2x times x will give us our 2x squared. And now 2 times something will give us minus 6x. Well, that's going to be minus 3. Minus 3 times 2x gives us minus 6x, so a minus 3. And down here we've got x times something gives us 3x, so x times positive 3. So just checking with the final box here, minus 3 times 3 gives us minus 9, so we appear to have filled in this correctly, and we've got our 2 factors. Okay, so I can now factorize, and I've got 2x plus 3 in my first pair of brackets, and in my second I've got x minus 3 equals 0. Okay, so it's just checking. 2x times x gives me 2x squared. My middle term, so I've got 2x, my outer here, 2x minus 3 gives us minus 6x, plus 3x gives us minus 3x in the middle, and 3 times minus 3 gives us minus 9. So worth just checking as you're going along, make sure you've factorized correctly. Okay, now the final stage is to solve for x. So again, if I use a separator here, let's see what we've got. Well, first of all, let's just do this one because this is the easiest. We've got x minus 3 equals 0. So if that's the 0 term, then x minus 3 would equal 0. Therefore, x, if I add 3 to both sides, will give me positive 3. So x equals 3. And here, I've got 2x plus 3 equals 0. So we just need an extra step here. That's going to mean that 2x, subtract 3 from both sides, I'm going to get 2x equals 0 minus 3, so minus 3. Therefore, x equals negative 3 divided by 2. So, my answer is x equals 3, or x equals minus, and I can just rewrite this, minus 1.5 if I want to just ring the changes here a bit. Okay, so that should be the correct answers. Those are the steps that you have to go through, and I hope that was clear, because these really are the things that you want to be able to tackle on the GCSE. They're the ones that other people very often don't manage to get right. And if you can answer these correctly, then you're going to pick up quite a lot of marks.